This is a brief review of algebra skills. This is based on your algebra review, and you will find case 1 where the unknown is isolated but has another number added to or subtracted from it. The example given on your sheet shows x plus 7 is equal to 15. We want to solve for x. Because 7 is added to x, we need to remove this portion from our equation. We are going to subtract x on both sides of the equal sign. This gives us the resolved equation of x equals 15 minus x. 15 minus 7, where x is equal to 15 minus 7, which is 8. That is how we solve for x whenever we have a situation where we have addition or subtraction. Our next case is when we have what is called a coefficient. A coefficient exists whenever there is a number in front of a variable indicating that they're multiplied together. For example, 7y indicates that 7 is multiplied by y. If we have the equation 7y is equal to 42, we are going to have to eliminate this coefficient from the left side of the equation in order to solve for y. We do this by dividing both sides by 7. We usually draw a line underneath both sides of the equation to indicate that we are doing division. Dividing both sides by 7 will eliminate 7 from the left side, leaving us with only y. On the right side of the equation, we have 42 divided by 7. This leaves us with the resolved equation y equals 42 divided by 7. 42 divided by 7 is 6. And that is how we solve whenever we have a coefficient. In case 3, we will have situations sometimes where our variable x, y, z, or whatever we may have might be on both sides of the equation. For example, in the equation 8x plus 5 equals 14x minus 13. In this situation, we need to move one of our x's with the coefficients over to the other side. For this example, I'm going to move 14x. The way I do this is by subtracting 14x from each side. Remember this cardinal rule: if you are subtracting from one side, you have to subtract the same thing from the other side. This is where it gets a little tricky. 8x minus 14x is similar to saying 8 minus 14. You're going to be left with a negative number. This will leave us with negative 6x on the left side. However, 14 minus 14 on the right side, that leaves us with 0. 0 minus 13 is the same as saying negative 13. Just as in the first example, we then have to move the 5 over to the other side of the equation. We do this by subtracting 5 from each side. This leaves me with negative 6x is equal to negative 18. The final step is going to be to move the coefficient by dividing both sides by the coefficient in front of x. The coefficient in front of x is negative 6, so we'll divide both sides by negative 6. Note that that cancels out on the left side, leaving us with only x. Negative 6 divided by negative 6 is 1. 1 times x is x. On the right side, negative 18 divided by negative 6 leaves us with 3. And that's our solution. The final case we will commonly deal with is whenever our variable x, y, z, a, b, c, it could be any letter, whenever that variable is under a radical, or otherwise known as a square root, or it could be raised to a power. So let's take the example of the radical of 9x, the square root of 9x. That is added to 5 equaling back up here. That is added to 4 equaling 5. In order to solve this equation, let's first move that plus 4 over to the right side. We'll do that by subtracting 4 from each side. That will cancel. On the right side, we will be left with 1. That leaves us with a radical of 9x is equal to 1. In order to get rid of a radical, we have to add a square root to it. Sorry, we need to add a square to it. So we will square both sides. If you do it to one side of the equation, you have to do it to the other side. If we square a radical, the radical disappears. If we square 1, the result is 1. 1 squared is equal to 1 times 1, which is just 1. Therefore, x equals 1 divided by 9. Finally, occasionally we will have x raised to a power, such as in the example 4x squared plus 7 equals 56. Again, because of order of operations, we want to get rid of this plus 7 first. We're going to subtract 7 from both sides of the equation. That will be eliminated on the left side. 56 minus 7 on the right side will leave us with 49. That leaves us with 4x squared on the left side. We can now take the square root of both sides. Whenever you take the square root of a coefficient, which I'm underlining in blue, as well as a variable squared, you take the square roots individually. So the square root of 4 is 2. The square root of x squared is simply x. Remember, the square root of a square is always that number. The square root of 49 is 7. Again, dividing to get rid of the coefficients in front of our variable, we have to divide by 2. We have to do it to both sides. That leaves us with x. Equals 7/2. Now try it on your own.